This apparatus is a single-bore capillary rheometer. It is used to examine the rheological properties of plastics. For example, how a material's viscosity changes with shear rate under specified conditions of temperature and capillary size. It consists of a heated barrel into which a material is placed and melted, a capillary to which the polymer melt is extruded, a load cell or pressure transducer to measure the force required to extrude the melt, and a motor to force the extrudate through the capillary at single or multiple shear rates. To perform the test, a plastic sample in the form of pellets or particles is placed in the barrel and allowed to melt for a specified period of time. For viscosity versus shear rate data, at the end of the melt period, the sample is extruded through the capillary at multiple shear rates, typically from highest to lowest, and the viscosity is recorded at each shear rate. The data is recorded, and a viscosity versus shear rate curve is generated. Here is a typical apparent viscosity versus apparent shear rate curve. We say apparent because the data has not been corrected for error related to non-Newtonian flow, which most polymers exhibit. As we can see from the curve, we go from a plateau representing the zero shear viscosity, where the viscosity is not dependent on shear rate, to an area with increasing amounts of shear thinning with increasing shear rates. Typically, if one was going to report the viscosity of a polymer, it is important to note the shear rate at which the viscosity was recorded.